universe was once smaller than an atom, hotter than any star, denser than anything we can imagine. Then, in a fraction of a second, everything changed. This was not an explosion in space. Space itself did not exist yet. This was the birth of space, the birth of time, the birth of everything. The Big Bang. Not a bang you can hear, but a bang that set the universe in motion. In the first microsecond, the cosmos expanded faster than light itself. In that first second, more happened than in the billions of years that followed. The universe was a cosmic furnace, forging the laws of physics and the seeds of all future structure.
The Big Bang. I've heard the term my whole life, but seeing it, it's different.
The term Big Bang was actually coined by a skeptic, Fred Hoyle, who believed in a steady-state universe, used it mockingly on BBC Radio in 1949. He meant it as an insult, but the name stuck.
So the name we all use today started as a joke?
Science has a sense of humor sometimes. But the evidence was overwhelming. In 1964, two astronomers, Penzias and Wilson, discovered a faint noise coming from everywhere in the sky. They had found the cosmic microwave background radiation, the afterglow of the Big Bang.
The echo of creation, still traveling through space after 13.8 billion years.
This is the cosmic microwave background, a snapshot of the universe when it was only 380,000 years old. The tiny variations you see here are the seeds of every galaxy, every star, every planet that would ever form.
So every time we look at the stars, we're looking at the Big Bang, at those seeds,
at our own origins. Let's start with the first pillar of evidence, the cosmic microwave background. This ancient light has been traveling for 13.8 billion years. It's the oldest thing we can see.
The temperature variations are tiny, aren't they? Just a few 100,000ths of a degree.
Exactly. But those tiny variations are everything. Without them, the universe would be perfectly smooth. No galaxies, no stars, no us. Over millions of years, gravity amplified these tiny fluctuations. Dense regions grew denser, pulling in more matter. They became the seeds of galaxy clusters.
So the cosmic microwave background is like a cosmic fossil. a snapshot of the universe's infancy, showing us the blueprint of everything that would come later.
Exactly. And this fossil is perfectly consistent with the Big Bang model. No other theory can explain it. The cosmic microwave background is the smoking gun. We've mapped the cosmic microwave background with increasing precision. Cosmic Background Explorer. In the 1990 years, Wilkinson Microwave Anisotropy Probe. In the 2000 years, Planck. In the 2010 years, each mission confirmed the Big Bang model with stunning accuracy.
From blurry patches to sharp detailed maps, we're literally seeing the universe more clearly every decade.
And the data matches the theory perfectly. The peaks and troughs in this power spectrum are exactly what the Big Bang model predicts. It's like finding a fingerprint that matches a suspect.
So, the cosmic microwave background isn't just one piece of evidence. It's a whole library of evidence, all pointing to the same conclusion.
Exactly. But the cosmic microwave background is just the beginning. There are two more pillars, and they're just as solid. The second pillar, the abundance of light elements. In the first few minutes after the Big Bang, the universe was hot enough for nuclear fusion to occur. Protons and neutrons fused into deuterium, helium, and lithium.
Deuterium? That's heavy hydrogen, right? Used in nuclear reactors?
Exactly. The Big Bang model makes precise predictions. About 75% hydrogen, 25% helium, and trace amounts of deuterium and lithium. And when we look at the oldest, most pristine gas in the universe, that's exactly what we find.
So the helium in balloons, in the sun, in everything, was forged in the first few minutes of the universe?
Every helium atom not made in stars today was made in the Big Bang. About 25% of the ordinary matter in existence. A cosmic factory running for only a few minutes. We can test this prediction by looking at the most distant quasars. Their light passes through ancient gas clouds, and we can analyze the absorption lines. The deuterium abundance matches the Big Bang prediction perfectly.
Those dark lines, they're like fingerprints. Each element leaves its unique signature.
And the deuterium lines are exactly where they should be, with exactly the strength the Big Bang predicts. It's like the universe left us a signed confession.
So the elements themselves are evidence. The very atoms in our bodies tell the story of their birth in the Big Bang.
We are literally children of the Big Bang. The hydrogen in our water, the helium in our balloons, the lithium in our batteries, all forged in that first cosmic furnace. The third pillar, the expansion of the universe. In 1929, Edwin Hubble made a discovery that changed everything. Galaxies are moving away from us. The farther they are, the faster they recede.
So the universe is expanding, like a balloon being inflated?
Exactly. And if the universe is expanding now, it must have been smaller in the past. If you run the movie backward, everything converges to a single point, the Big Bang.
So Hubble's discovery wasn't just about galaxies moving, it was about time itself, about the universe having a beginning.
Run the clock back 13.8 billion years, and all the matter in the universe was compressed into an infinitely hot, infinitely dense point, a singularity, the moment of creation. 3 pillars, 3 independent lines of evidence, the cosmic microwave background, the abundance of light elements, and the expansion of the universe, all pointing to the same conclusion. The Big Bang happened.
Three different stories, all telling the same tale. The universe was born. It expanded. It cooled. And from that cooling we emerged.
And that's the beauty of science, Minto. It doesn't rely on one piece of evidence. It builds a case, brick by brick, until the conclusion is unavoidable. The Big Bang is as well established as anything in science.
Thank you for showing me that the Big Bang isn't just a theory. It's our origin story, written in the language of the cosmos.
Our origin story, and we're still writing it. Every new telescope, every new observation adds another chapter. The story of the Big Bang is far from over. But the Big Bang raises as many questions as it answers. What came before? What triggered inflation? What is dark matter? What is dark energy? The first second gave us the universe, but it also gave us mysteries.
Before the Big Bang, how can there be a before if time itself began at the Big Bang?
Exactly. That's the paradox. Time as we know it began with the Big Bang. So asking what came before may be as meaningless as asking what's north of the North Pole. But some theories suggest a cyclic universe, or a multiverse, or a quantum bounce.
So many possibilities, and we may never know which one is true.
Perhaps, but the journey of asking is what matters. The Big Bang gave us a universe full of mysteries. And we get to spend our lives exploring them. That's the gift. But we're not done exploring. The James Webb Space Telescope is looking deeper into the universe than ever before. It's seeing galaxies from just a few 100 million years after the Big Bang. It's rewriting our understanding of the early cosmos.
Maybe Webb will find answers. Maybe it will find more questions. Either way, the story continues.
The Big Bang was just the beginning. The universe has been unfolding for 13.8 billion years, and we, for a brief moment, get to witness it, to understand it, to be part of it.
So the Big Bang wasn't an explosion in space. It was the birth of space itself. The birth of time. The birth of everything.
And we are part of that birth. Every atom in our bodies was forged in the Big Bang or in the stars that followed. We are not just observers of the universe. We are the universe conscious of itself.
That's profound. We're made of stardust, but we're also made of Big Bang dust. The universe reflecting on itself.
Every time we look at the night sky, we are looking back in time. The light from distant galaxies has traveled billions of years to reach us. We are seeing the universe as it was, not as it is. And in that light, we see our own origins.
And in seeing our origins, we see ourselves more clearly. We are not separate from the cosmos. We are the cosmos.
Exactly. The Big Bang is not just a scientific theory. It's a reminder that we are all connected. Connected to each other, to every star, to every galaxy, and to the very beginning of everything. The Big Bang, the moment when everything began, the moment when space, time, matter, and energy burst into existence, the moment that set the stage for stars, planets, life and consciousness.
Thank you, Kaler, for showing me the beginning, for showing me where we come from.
That's what we do, my boy. We look back. We ask questions. And we carry the story forward. The Big Bang is our shared origin. And it's up to us to honor it by continuing to explore.
The story continues.
And every time